Hello students, welcome back. I am Alejandro from Victory IB and CAIE Online Academy. During this video we will be discussing part A of problem number 3 of the 2019 AP Physics 1 exam. Now this problem, as well as the entire exam, is divided into subparts, so make sure to watch all the videos to have a complete understanding of all the concepts that are involved during this exam. Let's get started. Okay, problem number 3, a 12-point problem which you have suggested time of resolution of 25 minutes. It goes like this. A projectile launcher consists of a string with an attached plate as shown in figure 1. When the spring is compressed, the plate can be held in place by a pin at any of three positions A, B, or C. For example, figure 2 shows a sealed sphere placed against the plate, which is held in place by a pin at position C, right here. It's preventing the plate from moving rightwards. The sphere is launched upon release of the pin. Okay. A student hypothesizes that the spring constant of the spring inside the launcher has the same value for different compression distances. Part A. The student plans to test the hypothesis by launching the sphere using the launcher. Now, why is this underlined? Well, my guess is that we are expected to, well, let's read it. To state a basic physics principle or law the student could use in designing an experiment to test the hypothesis. Now, the hypothesis assumes that we're going to use the launcher. Okay, we're not allowed to give an answer in the way of, I don't know, take out the spring and use it on a separate experiment to, I don't know, using Hooke's law to hang a mass from it, and we're not allowed to use the spring without using the launcher. Okay, so don't be creative in here. So what is the basic principles that we can use? Well, we can use the conservation of energy, because when the spring is compressed, a certain amount of energy is stored in the form of elastic potential energy, which upon the release of the pin will be converted into kinetic energy of the sphere, converting all that energy into an energy which is going to be related to the velocity of the sphere. So the basic principle that the student could use is the principle or law of conservation of energy. So it's just a state, okay? The law of conservation of energy. Conservation of energy. Using the principle or law stated in part AI, determine an expression for the spring constant in terms of quantities that can be obtained from measurements made with equipment usually found in a school physics laboratory. Okay, so nothing fancy in here. The law of conservation of energy will state that the initial amount of energy, let's leave that initial energy, will be equal to the final amount of energy. For the initial energy, we are going to be using the expression for the elastic potential energy, which is 1/2 of the spring constant by x squared, x being the compression on the spring. And that equals the kinetic energy when the object is released, 1/2 of its mass times velocity squared. Now, this is the expression, but we are asked to find an expression for the spring constant. Okay, so we'll need to make this k the subject of this equation. Let's work it out. 1/2 on the left side, 1/2 on the right side can be simplified, and we'll end up with something that will look like this. Spring constant equals mass of the object times velocity squared divided by the initial compression squared. Or if you prefer, you can write it as mass times the square of the final velocity divided by the initial extension. Okay, thanks for watching. Please do watch our next videos for the remaining parts of this problem as well as the remaining parts of the exam. Also, don't forget to register on our website www.victoryonlineacademy.com for free demo registration. I'll see you all on our next video.